Hello, everybody. Welcome back to another episode of Rethinking Connectivity. My name's Jeremy, and today we're going to be going over the authentication and authorization model inside of NATS, essentially our security model. Now, this is a really big topic to cover, but I figured we've gotten a lot of requests for us to cover it. So today we're going to dive in deep, and I'm going to go over the overall architecture and some of the design choices that we made around building a security model like this. And then we're going to dive in and we're going to actually sketch one out using a tool called NSC and applying it to our NATS server. And I could show you all the different ways that you can kind of lock down certain accounts, that you could share between accounts, et cetera, et cetera. So let's dive straight in. So what is it that we call decentralized auth? Authn and authz and NATS? Well, it's a couple of pieces. So there's a couple of core concepts that I want us to kind of understand before we dive into some of the architecture. The first one is that we've split apart authentication, meaning, hey, I am who I say I am, and authorization, here's what I'm allowed to do. We've split those two things apart. Some systems, they put them together, and it causes all sorts of problems. We decided to tease these apart very early on. And so we expressed authentication, hey, I am who I say I am, through a technology we've created called N-keys, which is just basically an ED25519 based public-private key pair. And this is there to say, hey, I have a key pair that I can use. I can use my public key in public to say, this is my identity, and I can use my private key to essentially verify that identity by signing things like nonces, and also being able to use this in a hierarchical way, which I'll explain in a sec. The second part is we have our JOT, our JSON web token that we use for authorization, meaning here's the things that I can do. Here are my limits on the amount of messages I could send, or the amount of connections I can have, or what kind of subjects I can publish to or subscribe to. All of this stuff is easily expressible inside of this JWT. The last part is this kind of security model. We call it our operator model, which is this hierarchy of an operator of a NAT system going into having multiple accounts in a NAT system, and those accounts having multiple users. So let me kind of show you a more visual way of how this is expressed. Now, a NAT system can be a single NATS node, it can be a leaf node, but it could also be a cluster or a supercluster. But a single NAT system kind of treats itself as a singular system that has one operator kind of operating it. And the best way that I can kind of describe what an operator is it's an entity that is essentially operating this cluster at an infrastructure level. And so you can kind of think of it as maybe your team is operating a NATS cluster, then your team is kind of the entity that's this operator. Maybe you're operating a NATS cluster across an entire organization as a utility. And so your company name, Acme Corp, would be your operator here. Underneath an operator, you have accounts, and these accounts are completely segregated entities inside of a NAT system, meaning they could send their own messages and subscribe and publish their messages, but it's all happening inside of that account. And by default, you can't really cross accounts via messaging unless you explicitly describe it in imports and exports. So you can have one account exporting a certain subject or stream, and another account importing that. And that's a really this is a really powerful construct that allows us to do very cool multi-tenancy, where we can actually have, for instance, here at Synadia, we have a global network that we have multiple companies using one NAT system, and they're all separated via accounts. Inside accounts, you have your actual users. These are kind of like the end users of your NATS messages. This would be kind of like a microservice or a producer or consumer of a stream. These are the programs that are using them. And this is really where you can get into some fine-grained permissions around, hey, what are they allowed to do? What kind of messages are they allowed to subscribe to? And what messages are they allowed to publish to? Or what subjects are they allowed to publish to? What are their limits? All of these things can be defined in a user. Now, I mentioned up here a little bit before that we have these two kind of core concepts, the N keys for authn and JWTs for authz. And each of these has both an N key pair to essentially authorize this person's identity. But we also have a JWT kind of describing either metadata about the operator or account limits or user limits. And you'll see as we start exploring these JWTs why it's so powerful, because we can use these N keys to essentially mint JWTs and sign them so that we can verify up the trust chain that when I'm given a user JWT, I can verify that it's signed by an account that I know, and that account was actually signed by my operator. Let me show you what I mean here. So what gets stored on a NATS server? All this data. We have N keys, we have public keys and private keys for all of these different kinds of identities, and we have JWTs. Well, all that we really store are the account and the operator JWTs. We need to have the operator because we need to know who's operating this particular cluster or system. And then we need the account JWTs so that we can know when a user tries to authenticate, who it's coming from. Do we know about this account? Did they sign this JWT from a user? And so what doesn't get stored? Well, we don't store any user JWTs, which is really great because it means you could actually mint user JWTs without having to update it in the system. It's not like we have this one database of all of the users. It's actually decentralized, which is really, really nice. And then we store no private keys. Nobody's private keys enters into this system, which is another kind of zero trust construct that we've wanted to embrace in this design, which lets us essentially decentralize the signing process. Basically, the creation of accounts and users is all out of bound of the NATS system itself. Sure, we might have to push user or account JWTs so that the cluster knows about that account and can essentially verify users, but the creation process actually happens outside of NATS, which is a really, really cool thing, and it allows you to kind of decide what kind of systems you might want to embrace or build as you're thinking about, thinking through how to design something like this. Okay. So the last thing I wanted to cover was connecting. So a client connects to a server, right? We all know that. Once we get a TCP connection, the server's going to send back an info message, and this info message, one of the fields that it contains is a nonce. The client then uses its private key for its user. Remember, a NATS client is using a user identity. It's going to use this private key to sign that nonce and throw it in a signature field when it sends a connect message. It's also going to pass in its JWT, so we can know, what it can or can't do. And then the server asks itself a few questions as it gets that info. It asks, okay, is this signature valid, right? Did they sign the nonce with who I think they are? By the way, this JWT also contains the public key. So the server looks at the JWT, it looks at the public key, and is like, okay, was this nonce signed by the person holding this public key? Do I know that they're holding the private key as well? So they validate the signature. They also check if the JWT is valid. Hey, is the JWT expired, or has it been revoked? Was the JWT signed by an account that I know about? And was this account that I know about, did I sign it? And so it kind of verifies the user by going up the trust chain and making sure that everything was signed correctly. Once that connection is established, the server sets up a connection with the client and binds to all of the different claims on the JWT, which we'll explore in just a second in the code. But that's kind of the very basics of what it looks like for this decentralized auth and auth, how a connection works. It's actually really cool, and when you see it in practice, it's a really, really good way to go about it. It's extremely powerful. So why don't we just dive straight into the code, and I'll write up an example. Okay, so first thing we want to do is we want to install the NSC tool. So you can find this on the nats.io website or on GitHub. There's plenty of ways to install it for your system, but this is going to be the tool that we use to essentially, what I was mentioning before, manage that kind of out-of-bound creation of operators and accounts and users. Now, you don't necessarily have to use NSC, but this is the best way to get started, in my opinion, because you get to kind of get used to the workflow of what it looks like to create these. But remember that all of these things can be separate. I can create a operator identity, and then I can, I can hand stuff over to you as an account, and I can sign a JWT for you, but I don't have to know your private key or anything like that. So again, this works in a very decentralized manner if we want it to. In this case, I'm using NSC, and I'm going to just be storing all of the keys and all of the credentials locally on my machine, but there's plenty of ways to kind of work through this. It's a very open design, and that's on purpose because we wanted to make sure we hit as many different organizations' use cases as possible with a design like this. And so you can follow along with me and play with NSC. We're going to create an operator, some accounts, and some users, and we'll start playing with what it looks like to set up different permissions, what it looks like to share between accounts, and things like that. So for starters, let's create an operator. We can say NSC add operator. And the first thing we're going to do is we're going to generate a signing key with this. The reason we want to generate signing keys is we really don't want to use our root keys for anything. Root keys are great for printing out and putting in a safe when you're setting up a system like this. You generally want to use signing keys because if they're compromised, you can always rotate them, reissue new ones. If your root key gets compromised, you're kind of out of luck. So we want to generate a signing key just for good hygiene. We also want to generate what's called a system account. In previous episodes, we created a system account as well. This is just kind of a default service level account that we have in NATS systems that give us all of the kind of default permissions to be able to access things like monitoring and things like that. And then we need to give our operator a name. I'm just going to call this my org. Again, imagine that we are working at the same company together and we want to run a NAT system as a utility, meaning each and every team might get an account, and at some point, accounts might want to share between each other, but we want that to be like an explicit contract. And so I'm just going to call this my org for now. All right, and NSC tells me that it's created a signing key. It's created a root key for this account as well, and looks like we have all of our credentials stored. That's great. I'm going to do a couple other things to edit this operator. I'm going to say edit operator. And one thing that we want to do, again, for good hygiene, is we want to require all of our accounts to have signing keys as well. And then to make this convenient, we're going to set up an account JWT server URL. And this is just pointing to the NAT server that we're going to run. In our case, it's just going to be NAT 0.0.0.0 for 222, our default. Make sure I type that correctly. What this is going to do is it's going to tell NSC, okay, where do we want to push the account credentials, or the account JWTs. So when we create a new account or we modify an account, we can tell NSC to go push that to the server. So we'll do that. And it looks like we're set up with strict signing key usage. That's great. Let's go add some accounts. All right, NSC add account. Let's call this one Team A. Then we'll edit the account. We'll also, since we require signing keys before we can do anything, we'll just generate a signing key for it. Team A SK generate. There we go. We now have a signing key. And then let's add a user for this account with NSC add user. And we'll specify the account is Team A. Whoops. We need to name the account. We'll just name this user, or name the user. We'll just name this user A. There we go. We're going to do the same thing, but for Team B. So NSC add account Team B. We're going to generate a signing key for Team B. And we'll add an account for Team B. This time, I'm going to call this math because actually I have a little program that does a little bit of math. And I'm going to use that as kind of an example to share between the two accounts. So I'm just going to call this one math just for convenience. Okay, so we have a user, or we have two users, technically three because we have a system account. But what we're going to do is I'm going to say NSC list keys. I'm going to say give me all of them. And you can kind of see not only does it show our public keys for our root key pair, but also for our signing key. And that's why it's showing them twice. You can kind of see we have a system account with a system user. We have Team A with user A and Team B with math. And you can kind of see this hierarchy here, right? And so this is an easy way to be able to view keys. There's tons of different commands that you can use in NSC to kind of dissect a lot of these. But we have everything set up that we need. Now we need to go ahead and generate a config that a NATS server can use, so we can actually kind of consume this as our system. And so the way we do that is we can use NSC to generate config. And we're going to specify using a NATS resolver. For legacy reasons, we have other resolvers, and we even have one called a memory resolver, which does all of this in memory instead of storing it on the file system. And that's great for smaller systems, but if we want to have more, if we want to have things more dynamic where we can actually push accounts to servers, we'll want to use a NATS resolver for this. We also want to specify our system account, which is just sys, and then we're going to export this into a file called resolver.conf. So this is going to generate a, let's open this up. It's going to generate a configuration for our NATS server. You can also import this into an existing configuration pretty easily. But what it's going to do is going to say, here's my operator's JWT. Here's also the account that I want to use for system accounts, and we want to use a NATS resolver here. There's some settings around, when we push things and we want to persist things, some timeouts, things like that. We also preload with the system account just so we can bootstrap this a little bit more easily. But that's basically it. So I can use this config for my NATS server by just typing NATS server, specifying a config, and I'm going to say resolver.conf. You can see my NATS server spins up. The way we know this is working, by the way, is we can look at this little operator key, and it looks like it's saying the operator is my org. And it also looks like that it's managing JWTs in this JWT directory, which is great. Cool. So we have our NATS server running using our new resolver. Now we can push those accounts that we created to the server by saying NSC push all. And this is going to push all of these accounts to the NATS server. So it looks like it pushed sys, pushed team A, and it pushed team B, which is great. Okay. Up next, we want to be able to actually use the NATS CLI for these users. So I'm going to create a couple NATS contexts to be able to consume these. Remember, we've done this in previous episodes, but I'm going to just say NATS context save, and I'm going to name this my org sys for the system level account. And I'm going to use this NSC flag to say, hey, I know that the credentials are somewhere on the file system via NSC, and so I'm going to specify a path here so you know where they are. And we have actually a special NSC kind of pathing mechanism here where all it is you specify the operator, then the account, and then the user, which is very, very convenient. And so our operator is my org. The team is sys for the account, and then sys lowercase for the user. That's what was generated for the system account. So we're going to go like that, and we can see okay that we've gotten verified that this actually works as a credential, which is great. Now we want to say user A, and we want to grab from team A our user A credential, and we'll save that in the context. And then we will say my org math for that math user that we just created on team B. So we'll say math. Okay, so it looks like we have all of our credentials here inside of our NATS context now, and we can start using them. The last thing that we want to do is we want to run this math program that I created. I'm going to say vim main.go. So all this little program does is it connects to the NATS server, and one option that you can kind of notice here is that we have this nats.user credentials, and it's expecting that there's a file called math.creds here, and this is kind of the secret sauce that we have. Basically all a creds file is it's a combination of the JWT and the private key. It's basically anything that a client would need in order to make that connection that we talked about. And so we're going to export a math.creds file so this program can actually run. But let me just go over the file really quick. we're just subscribing to a couple different subjects and responding to them for math.double, math.triple, and math.quadruple. Very simple stuff, but this is just to represent kind of maybe a microservice that might exist inside of an organization. No left pad or anything like that. We're doing math.double. So we're going to use this. We're going to run it, but first we need to actually export that math.creds. So how do we do that? So we have a math user. We know we have its credentials somewhere in our key store using NSC, but we need to pull it out. So the way we do that is we say NSC generate creds, and we need to specify a username. In this case, it's going to be math.creds. And that's going to export a math.creds file. I'm going to cat this, but remember, this is sensitive information, so you might not want to always do this. But as you could see, the file has a user JWT, and then it has the N key seed, which is kind of our private key here. And so it's everything that the NATS client needs to be able to connect. Okay, over to my NATS server tab. Let's actually run this main.go file. So I'll say go run main.go. And silence is golden for this program, so it looks like it hasn't blown up, so we should be good to go. Let's go ahead and test this out. I'm going to use the NATS CLI to test math.double, and I'm actually going to use the math context. So we're going to say NATS context select my org math, because we know this is inside the Team B account, so we should be able to say NATS request math.double, and I'm going to bring in 42. So we get 84 back. So we're able to use the math user to request this service because they exist in the same account. It's actually the same user. But if I switched users, let's say I said NATS context select my org user A, and I try to do the same thing, it's going to say no responders are available because these two users actually exist in completely different accounts. The math service is running over here in Team B's account, while this user A, belongs to the Team A account. And so if we wanted to be able to use this service that Team B is running inside of the Team A account, we're going to have to use imports and exports. So let me show you how to do that. We can say NSC add export. We can specify an account. We're going to say we want to export from Team B, and we want to give this thing a name. Let's call it math stuff. We can call it whatever we want. Maybe we call it like math service. And then we say what subject do we want to export. In our case, we want everything, math.star, let's say. And we want to specify that this is a service. So imports and exports, it's probably another topic that I'll cover in another video, but the basics of it is there's either a service or a stream. A service is kind of a request response like we just did with math. A stream is access to data, and you can specify different settings for each of those. In this case, we want to say this is a service. So we want to export from Team B the math service, and that's going to be math.star. Cool. So now we have an export set up. Now we just need to add an import. So we can say NSC add import, and we'll make this interactive. And it says, okay, what team do you want to import something into? Well, we want to import something into Team A. Do we want to pick from locally available exports? Yes, we do. And I'm going to search math and look like math service, the one that we just created. Do we want to, what's our export subject? So we can filter this down to just math.double if we wanted to, but we're just going to keep it math.star. We can ignore this setting. The name, math service, we can keep the same. And then local subject. This is a way to kind of locally alias. So maybe we don't like math.star. We might want this to be called, I don't know, coolmath.star. We can do all of that. So, if somebody has a specific naming scheme for a service and you don't particularly like it, when you're importing it, you can name it whatever you want. And this is also just a really, really powerful construct in general. There's a lot more cool subject mapping you can do around it. We're going to keep it math.star for now. Okay, so now we've imported math.star. I'm going to do a final kind of NSC push all to push those updated account JWTs to our server. And it looks like everything is working properly. We're on our user A context. Let's see if math works. So we're going to say NATS request math.double, and now we have access to it, which is pretty cool. We also should have access to things like math.triple. Okay, so for the last thing, we want to be able to set up some limits. Maybe we like that user A can do math.double, but we don't like that they can do math.triple or math.quadruple. So we want to kind of lock this particular user down. Well, the way that we do that is we can, again, use NSC for all of this. And so we can use NSC to edit a particular user. So I'm going to say NSC edit user, and you can kind of see that there's a ton of different flags here that you can set up. But the one that we're looking for is we want to be able to look at allow sub and allow pub, right? And so allow sub is kind of what you would think is we can allow certain subscriptions, and allow pub is kind of the same. We can allow certain publishes, which is great. And so what we want to do is we want to specify these two as we're creating or as we're editing our user. So we want to say we want to allow to publish to math.double, and we want to allow it to subscribe to its inbox, which happens to be inbox.wildcard. This allows us to have kind of request response in here. Once I put in my very first allow pub, we really clamp down all of the permissions, meaning this user could only publish to math.double. If I wanted it to publish any other messages in this system, I would have to add these here. I could also put in some denies, so I could, maybe it's easier for me to just say, actually they have access to everything except they don't have access to math.triple and math.quadruple. But in this case, I'm just going to lock it down to everything except math.double. I'm going to be really vigilant in terms of my permissions here. But there's a lot of flexibility, as you could see, on what kind of claims you can add to this user. So I'm going to edit the user. I need to make the name, not math, user A. I think I need to specify the account here, team A. And we want them to only be able to publish to math.double and have an inbox. All right, so let's try that out with user A. So we've regenerated our creds file. We can now use the NATS CLI to say math.double. That should work. But if I want to say math.triple, we get an authorization error, which is great. Permissions violation for publish. So this is exactly what we would expect for a system like this. We can lock down our different users. We can specify what different accounts can import and export, and it all works pretty seamlessly in a very decentralized way. So I know this was a really long video, but I hope you guys really enjoyed it. I love making content like this. Please like and subscribe. Add some comments down in the YouTube comments if there is any follow-up that you'd love for me to dive in more, because there's a whole huge world to explore here in terms of claims and permissions and everything like that, and it could really lead to some interesting architectures. So I hope you enjoyed this video. We're going to be continuing to publish more every 1 or 2 weeks, and so I'll see you guys on the next one. Thanks so much.